Yes, it is. Let's start around the middle of the test. We start with problem number 13. A telephone number has the form ABCDEFGHIJ, where each letter represents a different digit. The digits in each part of the number are in decreasing order. Furthermore, D, E, and F are consecutive even digits. G, H, I, and J are consecutive odd digits, and A plus B plus C equals 9. Find A. Each letter represents a different digit. That's a lot of information to work with.
Eight.
I get the same thing, so tell me what you did.
They have to be consecutive. So you just pair up the ones on the ends, like the ends of the thing, on the ends of the evens, like 0, 2, 4, 6, 8. You pair up 0 and 8 with some 1 and 9, and just all of them but 1, and then you just find the one that doesn't fit, and then you just have the answer.
Okay, that sounds like some good playing around. I'm going to mention that between these two, with the odd numbers, there are more of the odd numbers, right? There's only 5 digits, so there's only 2 possible 4 consecutive digits. We either leave out the 9 or leave out the 1, but if we leave out the 9, then that would mean that one of A, B, and C is 9, but we can't have that, right? So it's got to be this right here. And that means that the 1 is necessarily over here. And then that means the other 2 digits, the 1 is probably the C, but A, maybe I shouldn't say that. The other 2, whatever they are, I'll just call them A and B, even though that may not be right, but they have to add up to 8. And the other ones are consecutive. 2, 4, 6 works. So these are not consecutive right here. There's 0 and 8. So it's actually like 8, 1, 0. Yeah. With A as the 8. Okay. Good work. Moving forward, number 14. I'll go ahead and copy this one and read it. A charity sells 140 benefit tickets for a total of $2,001. Some tickets sell for full price, a whole dollar amount, and the rest sell for half price. How much money is raised by the full price tickets? So where are you with this one?
Kind of got stuck with the equation.
Okay, well, let's talk about this. So I set up some variables, just turning the words into math, and I'm sure you got this far.
Yeah.
Set a variable equal to full price and two variables equal to the number of half and full price tickets. And really, we could probably just use one variable here, but I take it as far as this to substitute. And I go ahead and multiply out the fraction in order to get an equation where all the variables are integers. And so we are at this equation right here. Did you get this far?
Yeah. I got around there, but then I didn't know what to do with it.
Okay. This is a point where we're going to apply an idea that I like to call factoring is factoring. And what I mean by that is that we have algebraic factors on one side, and on the other side, we have a constant, an integer. And we can think in terms of prime factorization. And whatever these integers are on the left-hand side, p and a plus 140, those need to be integers that are divisors, a pair of divisors of 4002 that multiply to 4002. So we prime factor 4002 and we get 2 times 3 times 23 times 29. But one of these factors, a plus 140, what do we know about it?
It's 280 minus b. Wait, in the question, do you need to solve for the price?
No, it's how much money is raised by the full price tickets. So what we're solving for is a times p.
Oh.
But it's probably just best to find a and p, or maybe we could just find p and then subtract 140p from 4002.
Yeah.
That's one way to do it. But what is it that we know about a plus 140? Tell me anything that you know about that.
It's 280 minus b.
Okay. I understand what you meant by that now. Okay. Sure, that's true. I was thinking, like, what are the bounds of it? Like, what's the smallest it could possibly be?
141. Wait, no.
Sure.
Wait, oh yeah.
Maybe we could say 140.
Yeah. Oh, if
Zero
a is 0.
140. Well, 0 is less than or equal to a, which is less than or equal to 140. So we can add 140 to that and say the smallest that a plus 140 could be is 140, and the biggest it could be is 280. And maybe there are other reasons we could tighten the boundaries, but the point is that we are looking for a divisor in the range 140 to 280, and we find it at 174. So that means that the other divisor, 23, that means p is 23. That's the only divisor we did not use here. So p is 23. So we could either just compute 23 times 174, or we could subtract 140 times 23 from 4002. Either way, what do we get?
Oh, you get 402. If you multiply that out, so the answer is 174.
Wait a minute. The answer is not 174. 174 is
the price of the full price tickets.
Oh, wait a minute. Our answer is 23 times 34. Excuse me. It's the price times A, not the price times A plus 140.
Oh, and $782.
That is what I got as well.
Okay.
Let's peek up and make sure that's one of the answers. Yes, A, and that's correct. All right.
Okay.
Moving right along. All right, do you have any questions or other thoughts about that one?
No, not really.
That idea of factoring is factoring. You're going to
Yeah.
find that a lot because, it's one of the better methods that we have for common Diophantine equations where the variables are integers.
Yeah.
Okay, let's take a look at 15 now. A street has parallel curbs 40 feet apart.
I
Crosswalk.
feel like I've done this test before.
It's possible. I don't know what you've done or what you haven't. It's also possible you've seen some of the problems.
Yeah.
Oh, we need to draw this out.
$12.
I have not finished yet. So this is 15. Is that what they mean?
Yeah, I think that's what they mean.
50 long. Oh, so we have
Parallelogram.
find the distance in feet between the stripes.
I used area.
You use area. Okay, that's
Yeah.
good. I like that. Yeah, absolutely. Because we can find the area in two ways, and those are both base times height. So we could either say 40 times 15, or we could say 50 times the distance between the two, which turns out to be 12. Good. I agree. Okay, moving on. Nice quick work on that one. The mean of three numbers is 10 more than the least of the numbers and less than the greatest. The median of the three numbers is 5. What is their sum?
Mm. You could guess and check because they give you the numbers.
Possibly. I'll be honest. I'm not entirely confident of my interpretation of this problem. The mean of the three numbers is 10 more than the least of the numbers and less than the greatest. Of course, the mean is less than the greatest. Do they mean 10 less than the greatest?
Possibly.
Uh,
Hmm. It could possibly mean that, but then I don't think there's an answer if it means that.
This is unusual for me. I've read this problem 3 times, and I'm not sure if I'm reading it right.
I feel
Okay.
like I've done this one before, and I feel like I've done it correct every single time. But then when I read it this time, it doesn't seem right.
Okay. So let's. Okay. This is one of the. I've had these moments before. Um, sometimes a problem just. Sometimes you read it wrong, and you have to figure out why you're reading it wrong. And most of the time, that's the case. I mean, maybe there's something that we're missing here. So let's slow down and say the mean of the 3 numbers is 10 more than the least of the numbers and less than the greatest. Okay. The mean is 10 more than the least of the numbers. The mean is also less than the greatest. That seems
Hmm.
obvious.
But then if it's 10 less and 10 more, I don't think the question works out then.
The middle number of the 3 is 5. We've got 2 variables. Um, okay, I'm going to.
What was the solution they put up?
Okay, I'm gonna peek here, and I'll copy this, and we'll take a look at it. Let's figure out if this makes any sense. I'm actually gonna look this up on the internet and see if this
Oh,
problem.
it's supposed to be 15 more than the. Oh, the median is 50. The mean is 15 less than the greatest number.
Wow, that's a little strat. I don't think I've ever. If that's the case,
I feel like I've seen that before, but then it didn't pop up in this question. Where is it in this question, though?
okay, I just found another version of the problem, and it says and 15 less than the greatest, and as opposed to just and less than the greatest. So I'm sorry. This problem was just printed wrong. Okay,
Whoa.
then let's go ahead and move on to the next problem. I don't believe I have ever seen that happen with the AMC. I bet that they had like a misprint, and I bet they sent out like instructions to the people who were administering the exam. That was one of the years that I was not administering it. So,
Uh,
okay. Such is life. Moving on to number 17. Which of the cones below can be formed by a 252-degree sector of a circle of radius 10 by aligning the 2 straight sides?
Oh. Oh. That makes sense. Okay, I get it.
So what do we need to do here?
You have to find like the circumference of that part of the circle, and then that's like the circumference of like the base of the cone.
Yeah, when we bend this thing around, those blue links match up. Do I have the right one at C, or do you think it's D?
It should be C since the 10's the diagonal part.
I agree. Yeah. We're going to fold those two straight pieces together, and they're going to make a seam that goes down the diagonal. So we have C as our answer. Okay, let's take a look at 18. I love tilings.
Oh.
Percent of the plane is
56D.
50-60. You're a little faster than me here. Okay. So tell me how you got that.
Basically it's all the same for like it's basically a 3x3 grid, but instead in each grid there's four pentagons and 4 squares. And then the 4 pentagons form like 5/9 of the total area of the small square.
Oh yeah. I agree. It's funny. For some reason, I got stuck on thinking 44. But yeah, going back and reading the problem, the percent that is enclosed by the pentagons is closest to 56. Okay, we're in agreement, and I'll check it.
Okay.
And we are correct. Okay, good. Nice work.
Uh, 20? No, wait, no, that's too much. No.
I wasn't sure if we had worked problems like this before.
You could use sticks and stones.
Sticks and stones. Yeah,
Yeah.
and I tend to call that stars and bars.
Yeah.
But
Either
you're right.
way.
How many sticks or how many stars and how many bars?
You have 3 stars and 3 bars.
It's not 3 stars and 3 bars. It's 4 stars. We've got 4 of the donuts, right? 4 things that we have to pick in total. And we have 2 bars. What do the bars represent?
The types of donuts.
No.
The bars represent like wherever you put them, like the 3 spaces are how many donuts of each kind you want.
So I'm not quite sure if you said it the way that in a way that I think of it, but here, that's A. Here, that's B. Here, that's C. The bars are the separators between the variables. So the number of bars is 1 less than the number of variables. And now what do we do in order to count the number of ordered triplets that satisfy the Diophantine equation?
6 choose 2.
6 choose 2. Yeah, it is the number of ways to arrange 6 objects, 2 of which are bars. And that gives us a total of
15.
15. All right. Good work. And an octagon.
Ooh, octagons. I kind of set up an equation.
What was your equation?
So the part that's being cut up, the side of the octagon is x square root 2, and then the side is x. And then, so 2x plus x square root 2 equals 2000.
Okay, I've done the same thing. Now what?
You pull out the s.
And which one of the answers do you get?
2000. Oh, it's B. Oh, that's
It
why
is
I
B.
didn't.
That's
That's
right.
why I didn't. Oh, I set the equation kind of wrong.
Yeah,
Instead,
we
I
can.
made the side of the square that's been chopped off X instead of making the side X.
Okay, it
I
sounded like we had made the same equation. Did we not both have this?
no, I got X this S times square root of 2 plus 2.
Ah, okay.
I made it the opposite way.
Ah, got it, got it. Okay. Well, yeah, it's a good example of find two ways to express the same quantity. In this case, that same quantity was the side length of the square, since we could find that both in terms of the given information, the constant, and in terms of the variable that represented the side length. Okay, moving on. Number 21.
Hmm.
A right circular cylinder with its diameter equal to its height is inscribed in a right circular cone. The cone has diameter 10 and altitude 12, and the axes of the cylinder and cone coincide. Find the radius of the cylinder.
3?
You are ahead of me. I want to draw mine out carefully.
It was kind of wild, but I think it's it.
I don't think it's going to be 3, but I want to go slowly here. The cone has diameter, so radius 5 and altitude 12. And the cylinder has diameter equal to its height. So let's say the height is 2r is the way I'm going to do that. Okay, so what do we do with 3D problems like this most often?
Try to make it 2D.
Yeah, like maybe find a cross section, a
Yeah.
plane that we can most easily work with. And how do you want to slice this thing?
Kind of like down the middle, like it's a triangle with a square inscribed in it.
Okay, good. I like that idea. So here's our square on that slice, and our triangle. How does that help us?
Everything's 2D now, and similar triangles, maybe.
Now, I like to look for similar triangles in these situations. Of course, that is our most common problem-solving tool in hard geometry problems. But where do you see? Do you see similar triangles?
Um, Half of the big one, and then the small part that's been cut off by the square.
Yeah. I'm gonna go and tell me if this is what you mean. That right there, and then that right
Yeah,
there in the
that
little
small one.
corner. And when we set up, we've got height ratio of 2r to 12, and then the smaller leg ratio, or what I assume is the smaller leg, looks like 5 minus r to 5. Is that right?
Yeah.
Okay, and now let's cross multiply. and do our arithmetic. That is one of the answer choices, and that is the correct answer as well. 30/11. Okay, you feel good about this one?
Yeah.
Good, good. Let's move on. Number 22. Oh, we've got a magic square.
Ooh.
Out of curiosity, are you a Rubik's Cuber?
Yes. I have a 7x7.
I never tried with the crazy big ones.
Yeah.
I never got fast at solving the small one either. I have one, and I solved it one time on a car ride, but I've never learned how to speed solve.
Me neither. I just know how to solve it just in case somebody messes it up or not.
Okay, in the magic square shown, the sums of the numbers in each row, column, and diagonal are the same. 5 of these numbers are represented by variables. Find y plus z. Okay.
X is 22, right?
I don't know yet. How'd you come up with that?
Z is 3 more than V if it's a magic square. So then since Z is 3 more than V, 24 plus X plus 3. Wait.
Wait, z should be 3 less than v.
Oh yeah. Z should be 3 less. Yeah, I think it's still 22.
Okay, so we've eliminated a variable there. Sorry, and then what was your next step? What was your next move?
Try solving for W? W with V?
Okay, I got x is 22 also.
Yeah.
Okay, good. Then going through the middle row, we get 40 plus y. So v plus 3 equals y.
Yeah. So y plus z is just 2v.
True. Good observation.
So how do we find v?
That down left diagonal is w plus 47, has a sum of w plus 47. So w is v minus 4. Now we can go across the top row. What do we get?
2v plus 20.
And now we can solve for v.
Oh.
So what's our answer?
46.
I concur. And the key says that is correct. So I guess this is just a matter of, going along the equations and seeing where it is you can make relationships, replacing variables one by one, and the answer just kind of pops out for us.
Yeah.
A good lesson there is just to trust in the information and keep moving forward. Okay, let's take a look at problem 23 now. Box contains exactly 5 chips, 3 red and 2 white. Chips are randomly removed one at a time without replacement until all the red chips are drawn or all the white chips are drawn. What is the probability the last chip drawn is white?
So you count the ways you could draw 3 red chips first or 2 white chips first.
We could do that, something like that. But this one right here, we can completely reframe the question.
Oh, the last chip drawn, is it red or white?
Right. If you run out of white chips first, then you haven't run out of red chips yet, and vice versa. So what is the probability that the last chip is red?
Oh, the last chip is red.
You're overthinking this. Close your eyes, clear your brain. This is what you do when you've rearranged a problem, is clear your mind, look back at the wording. What is the probability that the last chip is red?
A fifth?
So 1/5? Is that what you said?
Yes.
That's not one of our answers. There are 5 chips. 3 are red, 2 are white. What is the probability that the last chip is red?
I feel like I'm overthinking this.
You're definitely overthinking this. You let yourself get caught up in one direction, and when you recognize something that's new, you've got to kind of back away and close your mind to that, and just right, like this reinterpretation. The point is that we've made this far simpler. There are 5 places to put chips in a sequence. 3 are red and 2 are white. We are looking at the very last chip. What is the probability it is red? Let's say that we're going to take that chip and we're going to glue it to our forehead. There are 5 chips. What is the probability that the chip on your forehead is red?
3/5.
3/5, yes. The last chip is still any old chip out of the 5. So yeah, 3/5 is our answer. Okay, let's move on to problem 24.
Oh, wow.
That's good. You know, those moments are moments where we learn, right? Oops, I had meant to grab this and move it up here. You know, we could just write it. There are 5 choose 2, 10 ways to draw them out. So, if nothing else, we can always brute force, right?
Yeah.
And sometimes, if you wind up with extra time on the test, then brute forcing to check is never a bad idea. Okay, trapezoid ABCD. AB and CD are perpendicular to AD. AB plus CD equals BC. Okay, I gotta draw this out here.
Oh, wait. Oh, you just solve for that because the x squares and y squares cancel, and then you have xy at the end left over.
That's right. What are we going to get?
49 divided by 4, which is 12.25.
I agree. And x times y is what we were asked for. And that turns out to be B, and that checks out with the answer B. All right, nice work. Sometimes we don't even have to find the actual variables themselves in order to find.
It's like most of the times when they give us a variable question.
Not most of the time, but it does come up often enough.
Yeah.
And that's reality. Sometimes in problem solving, we're not trying to find a variable, just a function of a variable or of multiple variables. Okay, number 25. How many positive integers not exceeding 2001 are multiples of 3 or 4, but not 5? What am I doing?
Drawing a Venn diagram.
Good. The simplest tools are often the best.
You could just find a whole thing and just subtract off the number of 5s.
What does that mean in terms of the Venn diagram?
Um, hmm.
So what we want is anything that is in the union of A and B, but is not in C. That's squiggly, means the
Oh,
complement of C, not C.
so you add up the ones in the multiples of 3 and 4, but subtract the multiples of 12, and then subtract the multiples of 3 and 5 and 4 and 5.
Possibly, we want the red region, right? There are a number of ways to get the red region. The way that I want to get, I look at this and I think, hey, we want the union of A, B, and C minus everything that's in C. To me, that's easiest. How do we find the union of 3 sets most easily in a case like this?
Add up them all and subtract the parts they share.
So we're using the principle of inclusion exclusion. We add each set. Then tell me what we subtract. Okay, so you've used pi a little bit, the principle of inclusion exclusion, but not enough. So let's get a little practice here. We add each of the sets. We subtract out the intersections 2 at a time. And then we add back the intersections 3 at a time. And if there were more, we would go back and forth, adding and subtracting, adding and subtracting. And then here we're going to subtract off C still. That's still that right there. That's the stuff that we are leaving out of the whole union. And that cancels out with part of what we've got on the inside here, principle of inclusion, exclusion. Now, this may or may not have been clear. I liked the idea of using intersections. Why is that? What is an intersection between 2 of these sets or 3 of these sets?
The intersection between.
Well, first, what's the size of set A?
The multiples of 3 under 2,000.
Yeah. Is it up to, it says not exceeding 2001? Yeah, so.
It includes 2001, right?
Yeah, we are allowed to include 2001. So that's the number of multiples of 3 and the number of multiples of 4. What is A intersection B? What does that mean? We're counting up the set A is the multiples of 3, set B is the multiples of 4. What would be in the intersection of those two sets?
Multiples of 12.
Right. And then what is the intersection of A and C? What are we counting there? Multiples of 3 and
15.
multiples of 5 are multiples of 15. Their least common multiple. And then B and C, we're subtracting multiples of
20.
And then finally, if it's an A, B, and C, then it's a multiple of
60.
Yeah, multiple of the least common multiple of 3, 4, and 5, multiple of 60. And now we have some arithmetic to do.
How fun.
It's not too bad. 2,000 is kind of a nice round number, right?
Yeah.
So some of this won't be the worst. And if we just multiply 2001 by 3, then we can divide that by 4. And we get 166, I hope. Divide that by 5, we get 133. Tell me if you get what I get.
Yeah, I got it.
Okay, and just to be sure, I will check the answer. And yes, 801 is the answer, and that is our choice B. So that was a good one to walk through. So you've made use of the principle of inclusion exclusion a little bit. Maybe next time we work, we can pull out some more counting problems that involve that so that you can build up some practice. That is absolutely, it's one of our most important, one of our most important counting skills is to think in terms of sets and to count up, intersections and unions, and principle of inclusion exclusion pops out of a lot of that. It's also a good idea when you see these problems to get in the practice of writing out what it is you're counting in terms of set notation. And I'll point this out. Writing that not C in front, we could write not C as C complement, and that's a way you'll see it sometimes as well.
Yeah, symbols are kind of weird. The U and the N.
Well, I hope that was fun. Thank you for joining me.
Thank you.
And I'll see you next time.
Bye.